See, there are two approaches to prove these kind of questions. Whenever we have to show, first up, like suppose we have to show fx, integral of fx from a to b lies between, say, capital A to capital B. Now first of all we apply estimation theorem on this. According to estimation theorem, integral a to b fx dx lies between, or we can say less than equal to, maximum value of fx, absolute max of fx in interval a to b multiplied with b minus a, width of the interval. So definite integral of fx from a to b has a upper bound equal to this, and also a lower bound equal to minimum value of, absolute minimum of this expression, global minimum of this expression multiplied with width of the interval. Now if we have, suppose this is the question, this is what we have to show, so we'll apply estimation theorem on this. And in case estimation theorem does not work on this, and that will happen when we have to show an integral a to b fx dx is like, if suppose we have, this is 5 and this is 10, this integral lies between 5 and 10, but we have to show this, the lower bound of this integral is 6. If it is 3, then this is not a problem. We can replace smaller number, we can replace lesser side by a smaller number. We could have replaced 5 by 3. But if we have to show lower bound is not 5 but say 6 or say 7, then this fails. This, if this is greater than 5, doesn't mean that this is greater than 7. Or same for upper limit, if upper limit is 12, no problem, we can replace 10 by 12, we can replace greater side by a larger number. But in case we have to show this is maximum value is 9, then this fails. This does not prove that this expression is less than equal to 9. So in this scenario where estimation theorem fails, we use this formula. We use this: if fx less than equal to gx for x belongs to, say, a to b, in interval a to b, then integral of fx from a to b is also less than equal to integral of gx from a to b. So we use this result in case estimation theorem does not work. Now this is like what we're going to show. We apply this formula, this result on this part, as well as we apply this on this part. Now let us start with this. Let us start with this. Now to prove this greater than pi by 6, we you know x cube is, in 0 to 1 interval, x cube is greater than 0, or you can say greater than equal to 0, minus x cube is less than equal to 0, because when you multiply with a negative number you need to change the sign of the inequality. Now we add 4 minus x square to both the sides, take square root of both the sides, take reciprocal. Now both the numbers are positive, so when you take reciprocal you need to reverse the sign of the inequality. So if this function is greater than this, then integral of this from 0 to 1 is more than integral of this from 0 to 1. So, and you know this is sine inverse x by 2. We take limit 0 to 1, this is pi by 6. So the see, we are able to show that the integral of this integrand is greater than equals to pi by 6, right? So this is not an easy question. I'll rate it as a difficult question, above difficult, because by inspection you have to think of a function which we have to compare with this. By inspection we have to think of this function, right? And idea is, sometimes the idea we apply is pi by 6 is a it's an irrational term. So when we integrate irrational term similar to this, when we can get answer pi by 6. So obviously will pi by 6 will get when we replace limits in trigonometric expression. And integration of an irrational function which gets a trigonometric expression would be like some formulas. The formulas we have, for example, 1 by root of a square minus x square, the sine inverse. So this is the way we have to think. Integration of irrational function that can give the trigonometric expression, and it should be similar to this. Now let's do the other part. For other part, we know when x lies between 0 and 1, x square is more than x cube. Minus x square get less than equal to minus x cube. So add 4 minus x square to both the sides. Take square root. Take reciprocal. If you take reciprocal, sign of the inequality will change. Oh, this is the mistake I have done. Sign was like this. So if we take reciprocal, sign of the inequality will change. Now integrate from 0 to 1. Now you can see upper bound on this is integral of this, and integral of this we can take square root out from denominator. 1 by root 2, 0 to 1 dx over root of 2 minus x square. Integral is sine inverse x by root 2 from 0 to 1, and you know this is pi by 4. So 1 by root 2 into pi by 4. This is the upper bound on this. Now you can see we are able to show lower bound is this, upper bound is this, and you can try yourself that this cannot be proved using estimation theorem. That is, you take this as function fx, find minimum value, find maximum value, multiply with the width of the interval, and you will see that it will fail.